We are looking at the definition of perfect squares. 2 times 2, well, that's just 2 squared, is 4. Negative 2 times negative 2, that's just negative 2 squared, is also 4. That's why when you take the square root of a number, you have to look at the plus and the minus, because the square root of 4 could have been 2 or negative 2. Same thing with 9. It could be 2 or it could be negative 2. So, would you agree that if 2 squared equals 4, then 2 equals the square root of 4? That they're kind of in reverse of each other.
Yes.
Would you agree with that? Good. Well, the point of this is, if you took, and that would go for negative 2 as well. Negative 2 squared equals 4. Square root of 4 could be negative 2. But if I had the square root of negative 4, by what we've just discussed here, nothing times itself can get negative 4. So technically speaking, the square root of negative 4 does not exist. Would you agree with that? But, as we've said over here, when you square a number, it just cancels the square root. So if I were to square this, I would get negative 4, because those would just cancel. The point I'm trying to make here is, you're going to have problems where it asks you to take the square root of a negative number, which technically speaking you cannot do. But what if later in the problem, you get to square it again, and then you don't have to worry about that square root of a negative number. So when mathematicians a long time ago looked at this conundrum, they said, well, that's impossible. But I guess if you squared it, it wouldn't even be relevant anymore. You could still have a number there. So rather than just disregard every time this happens, what they did was they said, what's just kind of a placeholder that we can put in there to remind us that, oh, that was a negative number. So here's what they did. What's the square root of 4? 2. And what they did was, if you took the square root of a negative number, they called it I. And they said the square root of negative 4 is 2I. And all that I does is remind us that this came from taking the square root of a negative number. So that if we square it again later, if you had to square 2I again later, 2 squared is 4. And this is something you need in your notes. And I have never seen an ACT that did not have at least one of these kinds of questions on there. I squared equals negative 1. It's I squared equals negative 1, which is why when you took the square root of negative, it became I. So, if I were to square 2I, that'd be 4I squared. But what's I squared? Negative 1. And you would get right back to negative 4. Point is, the only thing you really need to know about this from today is we're going to be doing some problems just like yesterday with these radicals. We're going to be doing problems just like yesterday. But when we take the square root of a negative number, you just pull it out and make it I out in front. Every time you see square root of a negative, you just pull an I. So if you have a problem that says square root of negative 9, that would be I radical 9, which would be 3I, because the square root of 9 is I. If you had a problem that said square root of negative 17, is that a perfect square? You have a calculator in front of you, hopefully. Is the square root of 17 a perfect square? No. So you really couldn't reduce that, but you can rewrite it as I radical 17. You see a negative, pull an I out in front. That's how we're going to deal with those. They're not technically real numbers, but we may end up getting to use those numbers later on in a way that I will go away, so we don't just discard them. Now, before we get to today's lesson, which you are going to need that, first thing I need is for everybody to 7, 9, and 11. All right, number 7. Stephen, what's the first step on all these problems?
Hit them on the same side.
Same side. So what do you think would be the easiest way to do that, Jared?
Add 6. Add 6b.
Thank you, Jared. Add 6b. That's correct.
What he said.
So that would be 5b squared.
You added to the 5b plus 3?
No, because one of them is squared, one of them is not. You cannot combine them.
Why can't you put the plus 6b in the middle?
Because you want them in descending order. That's where you went wrong over there, Justin. You have to have them in descending order. So, what's our A going to be?
5.
Our B
6.
and our C? 3. Oh, dang it.
So you don't bring the b and the squared with them. You just use them both.
That's right. That's right.
And the c is 3.
Yes, sir. Here we go. Now, again, the formula's up here. That's where I'm going to be plugging this stuff in at. If you can pull out the A, B, and C, the rest of this is literally just plugging it in, and then it's just going to be just like your quiz. You just punch it in the calculator. All right, so negative B is negative 6. B squared minus 4. A...
Where'd you get negative 6 at?
You gotta do the opposite.
Negative B. And our B was 6. Yeah. All over 2A. So, I always think you should always just punch the discriminant into the calculator. Remember, that's the number under the radical. So, if you punch 6 squared minus 4 times 5 times 3 in the calculator, what will it give you?
Negative 20.
Negative 24. Now, here's where your DOM comes into play. You cannot take the square root of a negative number. You can't. So what you have to do is, you have to pull it out as an I. So that'll be negative 6 plus or minus I radical 24 over 10. Once you pull out that I, it's going to become just like what we did yesterday. And you're not going to touch that I the rest of the time. It's just going to hang out there. That's just telling us that this answer is going to be an imaginary number, but we're going to keep going. Let's see. Can we factor 24? Let's see. 24, 4 and 6. Is there any number that occurs twice here?
2.
2. I can pull a 2 out, and what will that leave inside?
2 times 3.
A 2 times 3, which will be 6. So, I'm going to plug that in right here for this. So that'll give me negative 6 plus or minus 2I, because that I is still there, radical 6 over 10. At this point, we're almost done. There's only one thing we can do. 6, 2, and 10 are all reducible by what? 2. Yeah, you can divide all those by 2.
Where'd you put that? Where'd you get that 2 at in front of the 6?
We factored 24, because this was radical 24, right? We factored 24 and got 3 2's and a 3. And if you remember from that lesson we did a few weeks ago, on this particular problem, we needed to find things that came in 2's. We had 2 2's, and if we had 2 2's, that means we can pull one out. And then 2 times 3 was left, which is where the 6 came from. So if you divide all that by 2, just to reduce it, you get negative 3 plus or minus 1I radical 6 over 5. And that is your finished answer. That's what you need to have on your worksheet for number 7. Negative 3 plus I radical 6 over 5, and negative 3 minus I radical 6 over 5.
What happened to the 2?
You see how like all of those are even numbers? We just divided everything by 2 to kind of reduce our fraction. You know, like 4, 6, you reduce to 2/3. Same thing. We divided everything by 2, just not what's under the radical, and you got 3, 1, and 5.
That's by times 1.
Almost. Are there questions on that one?
That was terrible.
What was terrible?
All of it.
My paper looks like crap.
I'm confused.
You're always welcome to use the back of this paper too. What's your question on, Justin?
All of it. What is it?
Do you understand where we're getting A, B, and C from?
Yeah.
Do you understand how we plug those into the equation? Do you understand where?
No, because how do you turn it into like -6?
Because the formula is negative B, and if B is 6, then negative that will be negative 6. The formula is negative B. And then B squared minus 4AC all over 2A.
Alright, so if you have a negative for b or whatever,
then this would be.
positive.
Then from there, you just had to simplify the radical. The hardest part was just not even the I. The hardest part of these is if it's not perfect. If it's not a perfect square, you have to factor it. That's the worst part. Then you have to reduce that. And I would skip that step, but it's going to be on your next learning check. So,
Good time for lunch.
let's see. Now, first step is what?
Hey, yeah, same side. You're gonna let me do this. You're gonna wanna subtract 50 or add.
No, you're right.
All right. Now you got it on the right side. You're gonna get your A. A's gonna be 2. B's gonna be 50. And let's see what we got from here.
Would that just be a 0?
Yes.
Wrong.
Yes.
It'll be 1, won't it?
It'd be 0.
Be 0.
Wait, I don't know what we're doing. And then C's 50.
Now you're gonna wanna get your
C is negative 50.
But now how would you do B squared for the thing or whatever?
That's an excellent question.
Negative 0 squared.
No,
First,
You plug in an I.
because imaginary.
pause. Okay, you're overthinking it right now. You don't get to the I yet. Negative B would just be negative 0, which is kind of pointless, but I'm going to write it anyway. B squared minus 4AC all over 2A. 2 times 2.
So you just write negative 0?
Well, I mean, you don't have to write that at all, but I don't want people thinking I skipped that step. So, 0 is just 0, so plus or minus. What's 4 times 2 times negative 50?
Negative 400.
Okay, so 0 minus negative 400 is going to make that what? Positive 400 over, because it's minus negative 400, that'll make it positive 400. What is the square root of 400? Is that a perfect square?
200.
20.
How can it be a negative 0?
It's not. I just wrote that in there because that's part of the formula. You're right, it'd be 20. So that's positive 20 over 4, which is 5, and negative 20 over 4, which is negative 5.
So that's the answer, 5, negative 5?
Yeah, this one didn't have an I because there was no negative under the radical. It was just a positive.
Where'd you get both files
Because it's positive 20 and negative 20. All of these will render you two answers coming from that plus and minus. Questions?
So is that a negative 4?
No, it's positive.
Okay, so is it multiplying negative 15?
Oh, I see what you... Oh, up here. That's minus positive 4, positive 2, negative 50. You have to multiply 4, 2, and negative 50, and it's negative 400. But then it's minus negative 400, which is why it's positive 400. This is negative 400 when you multiply it. But minus negative 400 will give you positive 400.
Okay.
Yeah. Now the next problem I'm going to change ever so slightly so that we can practice the skill that we need to practice. Please look at your paper and change number 12. I mean, not number 12, number 11. Change that to a negative 10, please, on the right-hand side. Or the left-hand, yeah, right-hand side. That'll be a negative 10, not a positive 10.
What number?
Number 11. Change that to a negative 10. Do I need to leave this up there for a moment? All right, here we go. Now, like I said, I wanted you to change this to a negative 10. What's the first step to all these problems, Corey? What's the first step to all these problems?
Subtract the 10 on both sides.
And what? And what else? You need to get everything on one side of the equation. So you have to, well, I wasn't subtracting, I was changing that to negative. Because it's negative, you actually are going to need to add 10 and subtract 6 in from both sides. Plus 10 minus 6 in. That way it'll be 0 on the right. And on the left, it'll be 8n squared. 14n minus 6n is 8n. 2 plus 10 is 12. Now the reason I had you change that to negative 10 is because you'll be able to tell when you're going to have an imaginary answer or two. You're going to have imaginary answers when everything is positive or everything is negative. If you ever notice that in a quadratic every single piece is positive or negative, that means you're going to have an imaginary answer. So, now, one thing I did not mention yesterday, I don't think, I may have, I don't think so, is there a number that could divide evenly into every number here? Yeah, you could, at this step, you could divide everything by 4. Because remember, the fundamental theorem of algebra is whatever you do to one side, you just have to do it to the other. What? No, you don't. And it won't change your answer. But someone did ask me that yesterday. They said, can you do that? Will it change? It might make your numbers a little smaller later, but it's not going to change your answer. So, did you guys prefer to make the numbers smaller?
Yeah.
I heard a no and a yes.
No.
No.
All right, we'll just stick with the way it is and just plug it in as is then. What's our A going to be? Now, our A, just A, is 8. B is 8. And C is 12. So here we go. I'm going to run out of space, so hopefully you're keeping up because I'm going to have to switch pages here in a second. So that's going to be negative B plus or minus B squared minus 4 A C all over 2A. Now what I'm going to do this time is rather than show every single little step, I'm going to let you guys tell me what goes there. Will someone please just calculate the discriminant? That's the part under the radical. Would
16. Or maybe 64.
Did you have a calculator? What?
52.
Was it 52? Did you plug it in? 8 squared minus 4 times 8 times 12. You did all that.
No, it's like negative 920.
I thought you were talking about 2 times 8.
What about
No.
inside the thing, right?
Yeah, the discriminant. I just need the discriminant first. That always has to be your first step. Yeah, that should be right. Negative 320. So, that will give us negative 8 plus or minus the square root of negative 320 over 16. What's the first thing I need to do? Well, what's the next thing I need to do?
I can't read that. What is it? 320?
Negative 320. What do I need to do now? Exactly. Take the negative out and change it to an I. So that's going to be negative 8 plus or minus I radical 320 over 16. That tells you right there that even though you're going to have two answers, they're not actually going to cross the axis when you start graphing these. Now I'm going to stop there for a second so people can catch up, and then I have to go to a new slide.
I got a question about that 10 right there. Like, when you minus 10, and then you'll have a negative 10 on the other side, so then you'll have...
No. I told you to change it to a minus 10 originally. I said change that to a negative 10 because I wanted it to be, I wanted to have to add it to the other side. Before we started this problem, I told you to change it to negative so that we would get an imaginary answer. That's why I added it, not subtracted it. Are we all caught up? Who can tell me the next step that we're going to have to do right here? Is 320 a perfect square?
No.
No. So what do we have to do? We have to factor it. That's right. So here we go. Factoring 320. Let's see. I think that goes down into 2 and 160. 40 and 4.
My calculator does that.
Really? That's handy.
Honestly.
4 and 10. 2 and 2. 2 and 5. That is how 320 factors. We have 1, 2, 3, 4, 5, 6 2's into 5. That's how 320 factors. If we have 6 2's, we need pairs of them, right? We're looking for every time it occurs twice so that we can take it out of a square root. Very good. That's 3 2's that we can take out. Or you could just write 2 cubed. That'd probably be the easier thing to do. And then there's a 5 left in. What is 2 cubed? 8. We just reduced square root of 320 into 8 radical 5. Now I'm going to plug that back into my problem here in just a second after everybody's got this written down. So I'm going to erase this left-hand side. All right, we're almost done. So what was the problem? It was -8 plus or minus I, so 8I, radical 5, because it was radical 320, over, what was it, 16? Is there anything that all three of those front numbers divide evenly into?
2.
2, or what could be even bigger?
Leave the I in there.
Yes, you have to leave the I.
Nothing could be bigger.
Nothing goes into 8, 8, and 16?
8.
8, yeah. 8's
It's
the
gotta
biggest.
go to the 5 too, don't it?
No, what's under the radical is it's kind of like an X. It just kind of hangs around. So if you divide all three of those by 8, you get -1 plus or minus 1I radical 5 over 2. And that is your answer. Well, your two answers. -1 plus I radical 5 over 2 and -1. Now there's nothing else you can do. You can't combine any like terms. You can't do anything with the radical or the imaginary. You're done. And even though that's ugly, that is what your answers are going to look like on your next test. Just like that, with the eyes and everything. And if you tried to stop here, I mean, I guess technically I don't care in the homework, although you shouldn't, but it's not going to look like that on your test. It's going to look like this. So you need to know how to reduce that, or I wouldn't waste your time with that whole 320 stuff.
So do the last 3.
Yes, you need to do the last 3 on that paper, and I will come around and be checking if you did the 3 with us.